Good afternoon to everyone. My name is Saorabh Mandal. I am the Assistant Professor of Department of Applied Electronics and Instrumentation Engineering, Haldia Institute of Technology. Today I am giving a lecture on a very important topic named flip-flop from digital electronics. So what is flip-flop? Flip-flop is a very important sequential device which is used to store binary information data in digital electronics. Basically, flip-flop, we can say, the fundamental of sequential circuit, because for every sequential circuit, whenever we want to design, flip-flop is required. So without flip-flop, basically sequential circuit design is almost impossible. That's why sequential is the most important sequential device by which we can design sequential circuit, as well as the main function of that flip-flop that it can store 1 bit data in terms of binary information. But before going to start flip-flop, first we have to know the function of latch, which is other important term in digital electronics. First we will discuss latch. After that, what is the basic difference between latch and flip-flop? Then we will start flip-flop in details. Latch. What is latch? Latch is also one sequential device which can store binary information, but the main difference in between latch and flip-flop is that latch is unclocked sequential device. That means here no clock pulse is required. That's why whenever we will provide any input to latch, according to the input it will provide output in asynchronous way. So without clock, if we got any output from the sequential device, that is actually latch, where for flip-flop design clock is very important. So first we will see what are the various types of latch is present, and after that we will see the various types of flip-flop. So first, latch. Basically, the first and important latch which is available in market is SR latch. What is the full form of SR? S for set and R for reset. So why the name is like this? Because I already told that one, the function of latch to store binary information data, actually it can store 1 bit data at a time. That data is either 0 or 1. If it store 1, that means it indicates set. If it store 0, that means it indicates reset. So though only 2 states are available at the output side, one is set or another is reset, from that particular concept that S and R is coming. S for set and R for reset. So how to design SR latch? This is the circuit diagram of SR latch. SR latch can be designed two ways, by using NOR logic gate and by using NAND logic gate. Here I am drawing the circuit by using NOR logic gate. Okay. This is SR latch circuit. Now in this SR latch we have seen two input and two output. Among these two output, one is the main output, which is denoted by Qn plus 1, and another is the complement of main output, which is Qn plus 1 bar. Now this is a sequential circuit. Already I told that one. Now first we have to know what exactly sequential circuit. Sequential circuit are that type of circuits where the output not only depend on the input, parallelly it is also depend on the previous output. That means if we want to get a next output, then that next output value will be depend on the current input what we are providing, as well as which output already it has. Depending on both the parameter, the next output depends. Though it is the calculation of next output, that's why here Qn plus 1 that is indicated. That means Qn is the current output and Qn plus 1 will be the next output. We will going to face the next output in terms of Qn plus 1, and Qn plus 1 bar is the complement of that. So obviously these two will be complemented to each other. Here R is the input, S is also the input. So two input and two output, among them one is the main output and another is the complement of the main output. Now what will be the characteristics table of this latch, that we will see. So two input, so the total combination of input is the 4, 2 to the power 2 4. First one is 0 0, second one is 0 1, third one is 1 0, and fourth one is 1 1. Now whenever we'll put 0 0, then the output will be unchanged, or it is called hold. That means Qn. That means what is the present output, that will be the next output. It will not be changed. Whenever it is 0 1 or 1 0, then the output will be depend on the value of S. So 0 1, so the value of S is 0, so here the output will be 0. What will be the present output? Next output will be 0. For 1 0, again it is depend on the value of S, so here S value equals to 1, so the output will be 1. And for that case of 1 1, we are getting illogical value, or we can say it is undetermined value. So how we are getting this one, that we can analysis with the help of this circuit diagram. First we consider that one, the current output in this moment Qn, that is equals to 0, and we are providing R equals to 0 and S equals to 0. So whenever we are providing we are considering Qn equals to 0, so just consider that one. So this is Qn equals to 0, that means this is 0, so obviously this will be 1. Now this is 0, so this value will be 0, and this is 1, so this value will be 1. Now the thing is that whenever we are putting any value of non-logic gate 1 as input, then definitely the output will be 0. That we know. What will be the other input value? Not necessary to know on that moment, because one input is 1, that means obviously the output will be 0. So though for this first non-logic gate one input is 1, so obviously the output will be 0, and that output 0 is coming to this portion. Now in this moment the value of s, that is also 0, because we have already considered s equals to 0. So that 0 and 0, whenever this 0 and 0, the output of non-logic gate will be 1. So 1. So previously we have considered qn equals to 0, qn plus 1 also we are getting 0. That means no change. Same qn plus 1, 1, and now same thing, qn plus 1 bar is equals to 1. That means what exactly the current output by giving r equals to 0 and s equals to 0, r equals to 0 and s equals to 0, it will not be changed. Same thing, if we consider that when the present output is 1, instead of instead of 0 the present output is 1 and the complement of the present output is 0, then also we'll see, consider that one r equals to 0 and s equals to 0. So present output 1, so this value will be 1, this value will be 1, and this complement of the present output is 0, that means this value will be 0. So whenever we are providing this one, already we have providing this one r equals to 0 and here s equals to 0. So whenever we have providing s equals to 0 or r equals to 0, we will not conclude what will be the output of that non-logic gate. But whenever we are getting this output 1 which is connected to the second non-logic gate input, this value is 1, that means this output will be 0. So this output value will again become 0, and whenever it is 0, that 0 is going to this portion, so these two 0 will ultimately give the output 1. That means here also we have seen, if the present output is 1, then also the next output will remain unchanged. That means it concludes that whenever the s value equals to 0 and r value equals to 0, that means both the inputs are 0, then the output will be remain unchanged. The next output will remain unchanged to the present output. For that case of 0 1, what will happen? Consider that one 0 1. So in this moment I am considering s equals to 0, r equals to 1. And same, consider this, the present output is 1 and complement of present output is 0. So what will happen? This value equals to 1 and the one input of that NOR gate is 1. So the output, what will happen? Automatically the output will become 0. Whenever this output will become 0, this output is connected to here, so this output will be 0. Now whenever this one will be 0, so that 0 and this 0 will ultimately become this output 1. So the present output was 1, but after giving 0 1, it is changed to the present output 0. Instead of considering present output 1, if we are considering present output 0, we will see that it will remain unchanged, because that 0 is remain unchanged. From that particular portion we can conclude that one, whenever the s value will be 0 and r value will be 1, the next output will be 0. What is the present output? It is not depend on that value. Like this we can see, for that case of 1 0, the next output will become 1, that means it will depend on the s value. And for that case of 1 1, which is also very important, here we will not getting any logical value. Why I am saying it is not logical value? Because whenever we have given 1 and 1, just consider 1 and 1, and I already told that one, for that case of non-logic gate, if one input is 1, so output will be 0. So here one input 1, here for that case of second non-logic gate, one input 1. So in that particular case, according to the characteristics of non-logic gate, this value will be 0, this value also be 0. So both the value will be 0. Now whenever both the value will be 0, it is illogical because these two output are complement to each other. If one value is 0, other value should be 1. But here we are getting both the value 0. That's why it is called illogical or undetermined. That problem will be solved with the help of another type of flip-flop that I am coming after that. So this is the characteristics of SR latch. Now we'll see what is SR flip-flop. Already I told that one, the basic difference between latch and flip-flop is that flip-flop is the clocked SR latch. That means if we will connect clock pulse with SR latch, then only it will become SR flip-flop. So first I am drawing the circuit, after that I am discussing about SR flip-flop. So this is SR flip-flop. It is just the modified of SR latch. This particular portion is exactly same with SR latch. Only here I am adding one clock pulse circuit. That means two AND gate I am connecting with these two non-logic gate to provide the proper clock pulse. So here also two input, one input is R, another input is S, and two output, one is main output, another is complement of that main output. Now these two AND gate basically used here to provide the clock pulse successfully. This CLK is nothing but indicate the clock pulse. This is flip-flop. Here this clock pulse is there, which is not present for the case of latch. Now here, until and unless we are not providing the proper clock value, this flip-flop will not be work. This is the main interesting thing of flip-flop. For that case of flip-flop, until and unless we are not triggering with the help of clock pulse, that flip-flop will not provide the correct value. So if we are not providing clock pulse, then what will happen? Then the output will remain unchanged. What will be, we are changing the input R and S. If we are not properly provided the clock pulse, the output every moment will remain unchanged. Whenever after providing the proper input and clock pulse, then only the input is changed according to the logic. How it is happening? Because this particular portion is nothing but same of the SR latch. So here just consider that one, the proper clock pulse will be happen whenever we will provide the clock value equals to 1. So whenever we will provide clock value equals to 0, that means proper clock pulse will not be provided. So if clock value is equals to 0, that means this particular input is 0 and this particular input is 0. Now if we are providing one input of this AND gate is 0 and one input of this second AND gate is 0, what will be the output? According to the characteristics of AND gate, the output will be 0. So whenever we are getting the output 0, and already I told that one, this portion is totally same of SR latch. That means this two portion is 0 0. That means these two portion 0 0 means in SR latch R equals to 0 and S equals to 0, so the output will remain unchanged. That means in hold condition. But whenever we are providing 1, then this value will be 1 and this value will be 1. Now whenever one input of AND gate is 1, then we can't say what will be the output of that AND gate until and unless we are not sure what will be the second input of that particular AND gate. So whenever these two input is 1, then it is depend on the R value and S value. The output of this AND gate is depend on S value and R value. That means whenever we will provide proper clock pulse, then only according to the input of R and S, that particular circuit works. This is the interesting thing of flip-flop. That's why flip-flop provide us the output according to the synchronous way, but latch is provided us the output in asynchronous way. Whenever we will provide the input, it will change, provide the input, it will change the output. If the input is 0 0, it will be unchanged, but if it is 0 1 or 1 0, accordingly it will change the output. So this is basically the difference between flip-flop and latch. It is SR flip-flop. So what will be the characteristics table of this SR flip-flop? Here I am considering the clock value equals to 1, because if clock value equals to 0, in every moment the Qn plus 1 will be unchanged condition. So by considering clock value equals to 1, so 1 it is 0 0, 1 0 1, 1 1 0, 1 1 1. Then same result is coming. What result we have got for that case of SR latch? 0 0 means unchanged, unchanged means Qn value. 0 1 means the value of S 0, it is 1 and it is that means illogical. But whenever we are providing, just consider, whenever we are providing clock equals to 0, then for S equals to 0, R equals to 0, Qn 0 0 0 1 Qn 1 0 Qn 1 1. That means it will not change because the clock value equals to 0. So until and unless we are not providing the proper clock pulse, this flip-flop will not work. So what will be the state transition diagram of this SR flip-flop? This is called state transition diagram of SR flip-flop. So that means it is the state transition. That means one state to another state. Consider that this is the present state and this is the next state. So 0 to 1, whenever it is converting 0 to 1, whenever it is converting 0 to 0, whenever it is converting 1 to 1, whenever it is converting 1 to 0, that we have to be know. Now in which time it is getting, that we can know from the excitation table of SR flip-flop. Excitation table. What is excitation table? Excitation table is that table where we can understand from one state to another state which value of input, that means which value of S and R we are getting that state transition. Say from 0 current state to 0 next state, 0 current state to 1 next state, 1 current state to 0 next state, 1 current state to 1 next state. In which value of S and R we are getting this state transition, that we can know from which table. That table is known as excitation table. So excitation table, okay, Qn 0 and Qn plus 1 0. In which condition it is happening? That here I am drawing another one, from that it is understand. Say S R Qn plus 1 and Qn. Okay, 0 0 0, so it will be 0 0 0 1, so it is depend on S value 0 0 1 0, it is depend on S value 1 0 1 1, so it is illogical, so cross. 1 0 0, so it is Qn value 1 0 1, depend on S value 0 1 0, depend on S value 1, and 1 1, it is cross. Now from that particular portion, what we can know? Qn 0, Qn plus 1 0. So Qn 0 and Qn plus 1 0. Qn 0 and Qn plus 1 0. In these two positions we have seen Qn value 0 and Qn plus 1 value 0. So what is the value of S and R? In both the position the S value equals to 0, but the R value equals to 0 and 1. That means we can write S value equals to 0, but R value equals to D. D means don't care. That means the value of R may be 0, may be 1. Next 0 1, Qn 0, Qn 0 and Qn plus 1 1. Only this portion. So here the confusion is not present. So the value of S1 and the value of R 0. Value of S1 R 0. Next 1 0. So 1 and 0. This portion. That means this is Qn. This one. What is the value? 0 1. So 0 1. And last 1 1. 1 1 in this portion, it is, that means 1 0 0 1 1 for the case of 0 0, and another here 1 1 for that case of 1 0. So 0 0 and 1 0. That means R value 0, but S value don't care. S value don't care, but R value, sorry, S value don't care, R value 0. That means from that particular portion we have seen this one, that Qn 0, Qn plus 1 0, for S equals to 0, R equals to don't care. Qn 0, Qn plus 1 1, S equals to 1, R equals to 0. Qn 1, Qn plus 1 0, S equals to 0, R equals to 1, and Qn 1, Qn plus 1 1, S equals to don't care, R equals to 0. So from that particular portion we can write the state transition diagram. See 0 0, in which position 0 0? That means 0 to 0. Present state 0, next state is also 0. 0 don't care. So we will not consider the don't care, that means R. So S equals to 0. S equals to 0. What is the meaning it? That means it is reset condition. S equals to 0. S is indicating set. So S 0 means it is reset condition. So S equals to 0. That means reset condition. For 0 to 1, 0 to 1, S equals to 1, R equals to 0. That means set condition. S equals to 1, R equals to 0. For 1 0, 1 0, S equals to 0, R equals to 1. S equals to 0, R equals to 1. That means reset condition. And for 1 1, 1 1, it is S don't care, R 0. R 0 means that is the set condition, because R is indicating reset. If R value equals to 1, that is indicating reset condition, but here R equals to 0. That's why it is set condition. So it is R equals to 0, that means set condition. So this is the state transition diagram of SR flip-flop. Now we'll go to the next flip-flop, which is the modification of that SR flip-flop. It's D flip-flop. D means delay. Now first I am drawing the D flip-flop circuit diagram. After that I am explaining. So this is D flip-flop. So this D flip-flop is just little bit modification from SR flip-flop. Here we can see only one inverter logic gate is connecting in between R and S of SR flip-flop. So here instead of two input, one input is present, which is D. The meaning of D is delay. This flip-flop is basically provide us some delay. Why I am saying this one? Because the output of that flip-flop is exactly same of the input. If we are providing D equals to 0, the output will come 0. If we are providing D equals to 1, the output will come 1. So though the input and output is same, so it may have some question that so what is the necessity of that particular flip-flop? These flip-flop are basically providing the delay. Sometimes delay is very important to various circuit to get the proper output. So this circuit is providing such type of delay. Now here what will be the characteristic table of that particular flip-flop? Like this, though it is only one input D and the output Qn plus 1, 0 0 1 1. Same. Just I am considering this one. This is clock pulse as usual. So we have to provide the proper clock pulse. That means we consider that one, the clock value equals to 1. So if clock value equals to 1, so and we are considering this one D equals to 0. So D equals to 0. So D equals to 0 means this value will be 1. Now this value equals to 1. This value clock value equals to 1. So this is 1. This is 1. So that means 1 0. That will be 0. That will be 1. So that will be 0. That will be 1. For that case, so what will happen? In that particular case, ultimately we are getting this one. So ultimately we are getting this is 1. So this is 1 means this value, but this particular value will be, this is NOR gate, one input 1, that will be 0, and that particular value will be 1. Okay. For that case we have seen the output will 1. Okay. So we can say this one, this is Qn plus 1 bar and this is Qn. Yes. So this one. Now again we are considering this one. This value equals to 1. So this value equals to 1. So if this value equals to 1, so what will happen? This is 1. So it will be 0. It will be 0. So this is 0 and this is 1. So this is 1, clock value equals to 1, 1, 1. So this particular value will be 1. And this particular value will be 0. This particular value will be 0. Whenever this particular value will be 0, so what will happen? This is ultimately, this is basically the SR latch. This is basically SR latch. So this value equals to 0 and this value equals to 1. So what will happen? Ultimately, this value will be 1 and this value will be 0. So either we have to change the output portion, here it will be main output and here it will be complement output, or we can change one thing, that is we can change the direction of that particular inverter logic gate. In any way we can design the circuit. So we can change the position of the main output or complementary output for SR flip-flop where the main output was present. In D flip-flop the main output will be just opposite positions, and we are maintaining the inverter logic gate direction like this. Or if we are changing the inverter logic gate, it's like in this way. Then not necessary to change the main output and complementary output. On that particular time we can mention that one, this is the main output and this is the complementary output. So in any way we can design the D flip-flop, either by properly maintaining the inverter logic gate direction or by changing the output positions. So this is the characteristic table of D flip-flop. D equals to 0, output will be 0, D equals to 1, output will be 1. Okay. So what will be the state transition diagram? So here 0 to 1, when it will happen? When D value equals to 1, because in this particular circuit the output, that means next output is not depend on present output, it is only depend on the current input what we are providing. If D equals to 0, the next output will be definitely 0. If D equals to 1, the next output will be definitely 1. So 0 to 1, that means in this moment next output 1, so D value will be 1. 1 to 0, so D value will be 0. 1 to 1, next output 1, that means D equals to 1. 0 to 0, next output 0, so D equals to 0. So this is the next, another very important flip-flop, which is basically the modification of 1-1 input of SR latch. That means for that case of 1-1 for SR latch we are getting illogical output. To solve this problem, one modification SR flip-flop is there, which is called JK flip-flop. So JK flip-flop is designed to solve that particular problem which is occur when we are providing 1-1 in SR flip-flop. Now first I am designing the circuit, after that I am discussing. So this is JK flip-flop circuit diagram. Here exactly it is almost same of SR flip-flop circuit diagram, only two addition connections is present. That connection is that from output of non-logic gate to input of AND gate in both the positions. So these connections is happening additionally to avoid that problem which is occur in 1-1 condition in SR flip-flop. So with the help of this circuit actually, ultimately what we are getting, the characteristics table of JK flip-flop like this. For 0, 0, 0, 1, 1, 0, it is exactly same of SR flip-flop. That means Qn, that means same value. 0, 1 means 0. Here we are considering J with S and K with R. So for 0, 1 it is depend on J value, and 1, 0 it is also depend on J value. 1, 0, so it is depend on J value, so it will be 0. 1, 0, so it is depend on J value 1, and it is 1, 1. It will be 1, 1. 1, 1. Here actually it is changing. For the case of SR flip-flop, it is illogical, but here we are getting the logical value which is Qn bar. Qn bar. That means what is the output currently available here, the next output will be just opposite. That's why it is Qn bar. For 0, 0 it is same value. For 1, 1 it is the opposite value, Qn bar. That means for the case of 1, 1 it will provide the opposite output of current output. The next output will be the opposite of current output. If current output is 0, next output will be 1. If current output is 1, next output will be 0. So that is happening in this particular portion. I am giving just one for that case, 1, just K equals to 1 and J equals to 1. For that case, just I am considering in this moment Qn value equals to 0. So it is 0 and it is 1. I am considering. So what will happen? This is 1, clock equals to 1 as usual. So this is 1, this is 1, this is 1, this is 1. Now this value 1, so this is 1, and this value 0, so this is 0. So here output will be 0 because this is AND gate. One input is 0 means output 0, all 1, so 1. So 0 and 1. So in this particular portion 0 and 1. So what will happen? So this is exactly same in that particular portion. This particular portion is exactly same of the SR latch. So here 0 and here 1. So if we are considering this is R and this is S, so ultimately this value will be depend on S. So this one, so ultimately it will be changed to the 1 position. That Qn plus 1 will be changed to 1. Whenever it is changed to 1, just consider that one Q in the current output is 1. So current output 1 means complement of current output 0. So this value will be 0 and this value will be 1. So this value will be 1 and this value will be 0. So opposite, that means here according to SR latch, this is R position, so R equals to 1 and S equals to 0. So this value will be 0 and this value will be 1. That means every time what is the current output, the next output will be changed. If it is 0, it will be 1. If it is 1, it will be 0. So that problem which was occurred in SR flip-flop, that is not happening in this particular question. So JK flip-flop is the modification of SR flip-flop to solve that problem in the case of 1-1 condition. So state diagram. See, for that case 0 and 1 here it is happening. That means here also we have to be first write down the characteristics table. So characteristics table, just I am writing in this particular portion again Qn J K and Qn plus 1 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. For that case of 0 0 0 0 0, so it is depend on the current output, so 0 0 0 1 depend on J value 0 0 1 0 depend on J value 1 0 1 1, so it will be opposite to the current value, opposite value is 0, so it will be 1 0 0, so depend on current value 1 0 1 depend on J value 0 1 0 depend on J value 1 1 1, again it is opposite to the current value, so 0. So from that particular portion what we can see 0 to 0 0 to 0 means this is 0, this is 0, again this is 0, this is 0. So J value 0, K value 0 and 1, that means don't care. So J value 0, 0 to 0, J equals to 0, K value don't care, so not necessary to write K value, or J equals to 0. That means if J value equals to 0, then the next output will be 0 if current output is 0. Okay, 0 to 1, so 0 to 1, sorry, this is 0 to 1 this portion and 0 to 1 this portion, these two. So here J equals to 1, K equals to don't care, that means J equals to 1, so J equals to 1. Next 1 to 1, 1 to 1, this is 1 to 1 and this is 1 to 1. Here J value 0 and 1 but K value 0, so K equals to 0. And 1 to 0, 1 to 0, is there 1 to 0? Here and here, so 1 to 0, 0 1 and 1 1, so K equals to 1 but J equals to don't care, so K equals to 1. So this is the state state transition diagram of JK flip-flop. So from this diagram basically we can understand that what will be the value of the input by which the state will be changing. It may change or may not change. 0 to 0, that means not change. 0 to 1 changed, 1 to 0 changed, 1 to 1 not changed. In which condition of the input this will happen, that is indicating the state transition diagram. Okay. The last flip-flop, which is T flip-flop. The full form of T flip-flop is toggle flip-flop. That toggle flip-flop is totally coming from the JK flip-flop. That means if we are sorting J and K input, then it will become toggle flip-flop. So already we have seen the circuit diagram of J and K. So I am not drawing the J and K circuit. I am just considering one JK flip-flop. I have one JK flip-flop and I am sorting that JK flip-flop input J and K. So whenever we will sort J and K to maintain a single input instead of two input, then that input will become T and that flip-flop will become the T flip-flop. Okay. So first I am drawing the diagram. After that I am discussing. Here I am considering that this is JK flip-flop. That means inside this JK flip-flop that circuit diagram is present, which circuit diagram I have drawn previously. Now in this moment, instead of two input, what we have to sort these two input and totally design a single input, and that single input is named T. The name T is coming from the name toggle. From toggle that T is coming. So here one input is present, which is T, and one main output Qn plus 1 as usual, and one complement of main output Qn plus 1 bar. So from that particular connection we can design T flip-flop from JK flip-flop. So this is T flip-flop. Now why this flip-flop is called toggle flip-flop? Because this flip-flop will provide the output in toggling order. Toggling order means, that means if we continuously provide the clock pulse, then the output will be continuously changing. Because already we know that one, whenever the value of J and K 1 and 1, then the output will be the opposite of current output. So consider that one, in this moment the current output is 0. So we are providing clock pulse, and that according to provide the clock pulse, the output will be 0 to 1. Now after getting 0 to 1, again the clock pulse is remain high. That means consider that one, continuously we are providing the clock pulse high, continuously. There is no gap. Continuously we are providing the clock pulse 1. If we are continuously provide the clock pulse 1, then what will happen? The output will be every time changing, because after 0 to 1, again it is observing that one the clock pulse high, so again it will be changed. So 0 to 1, again it will be changed to 0, again that 0 will be changed to 1. Up to that time, when it will get the clock pulse high, the output will be changing. That changing output, that means that toggling output, from that particular concept, this toggle input is or flip-flop, and the input toggle is coming. So toggle flip-flop basically provide us the toggling characteristics with the help of J value equals to 1 and K value equals to 1. But when T equals to 0, what will happen? When T equals to 0, that means it is nothing but J equals to 0 and K equals to 0. So T equals to 0, that means and t equals to 1, so when t equals to 0, that means when this one is 0, that means this is 0 and this is 0. So when j and k is 0, then the output will be remain unchanged. But when t equals to 1, that means j equals to 1 and k equals to 1, the output will be just opposite of the current output. So what will be the characteristics table? T equals to 0, so it will be Qn, unchanged. T equals to 1, it will be Qn bar. So what will be the state transition diagram of T flip-flop? So 0 to 1, t equals to 1, that means the output, next output change from current output. 1 to 0, same, t equals to 1. 1 to 1, that means unchanged, that means t equals to 0, and 0 to 0, then also t. That means t equals to 0, it is unchanged, and t equals to 1, that means it is changed. So this is the state diagram of Now this JK flip-flop has one problem, and this problem is known as race around condition problem. What is this? The problem is whenever j value equals to 1 and k value equals to 1, then logically we should get the output complement of current output. That means if current output 0, it will be 1, if current output 1, it will be 0. But if we are not maintaining the proper clock pulse, then what will happen? Due to continuous clock pulse, that output may be again changed, and the final output will be uncertain, and it will be any value. Every time it will not maintain the complemented of current output. So if we are not maintaining the clock pulse properly, so one uncertainty output is coming during the time of j equals to 1 and k equals to 1. This one is called race around condition. In next class, we'll discuss race around conditions and other properties of flip-flop, that means conversion of one flip-flop to another flip-flop, and other advantage, disadvantage, and the application of the flip-flop. So thank you everyone. That's all for today. Thank you.